In this lecture, we are going to learn about gears and gear ratio. Transmission gears are torque and speed converters used to adapt the traction output of the electric machine to match the traction requirement of the vehicle. Let's take an example, a simple pair of gears where we have an input wheel and an output wheel. The input wheel has Z-in number of teeth, has a torque T-in applied to it, its radius is R-in, and is engaged with an output wheel which have a Z-out number of teeth, a output torque T-out, and the radius R-out. In the contact between the teeth of the two wheels, we'll have a tangential force Ft. Also, in the same contact point, we are going to have a tangential speed Vt. The gear ratio I is calculated as the ratio between the number of teeth of the output wheel divided by the number of teeth of the input wheel. The gear ratio can also be calculated by knowing the radius of the output wheel divided by the radius of the input wheel. For this example, let's assume that our gear ratio is 1.5. Also, let's assume that the input torque is 100 Newton meters and the input angular speed omega is 1000 radians per second. This 1000 radians per second is equivalent to around 9550 RPM. The force and speed equations are the following. So, as we know, we have a tangential force Ft, which is common between the input wheel and the output wheel. So Ft can be expressed as the ratio between the input torque divided by the input radius, or the output torque divided by the output radius. Since it's the same force for both wheels, both equations are correct. In the same time, the tangential speed Vt is the product between the angular speed of the input wheel times the radius of the input wheel, and it's equal with the angular speed of the output wheel times the radius of the output wheel. With these equations in mind and with the input data, we can calculate the output torque as being the product between the gear ratio and the input torque, which means 1.5 times 100 gives 150 Newton meters. Also, the angular speed of the output wheel is the ratio between the angular speed of the input wheel divided by the gear ratio, which gives around 667 radians per second. The same equation can be applied if we use RPM for the rotational speed. In this case, the speed of the output wheel is the ratio between the speed of the input wheel divided by the gear ratio, which gives around 6367 RPM. In conclusion, a gear with a gear ratio higher than 1 is a converter which takes an input torque and converts it into a higher output torque. In the same time, the higher input speed is converted into a lower output speed. With other words, torque and speed are converted, but power is conserved. Ideally, if we assume 100% efficiency, no losses in the gears, the input power will be equal with the output power. In reality, there are some losses in the gears, losses in the contact point between the gears, and also losses in the hubs. These losses make that the output power is a bit less than the input power.